Hello again, this is UML Operator. All right, today we're going to be talking about traceability in Spark's Enterprise Architect. And traceability I often refer to as relevance. Relevance between elements, any objects. An object could be a diagram, could be a package, or any element, object within your modeling environment. So when you're drawing connectors, often referred to as associations, and there's different connector types or association types. We're telling a story within our models, and that's what we're going to cover in today's session. So let's start with association. And in this case, we just have a simple line between two elements, meaning there's a relationship between class 1 or object 1 and class 2 or object 2. Let's start with reflexive association, meaning that the element has an association with itself. So when we look at traceability, we can see that the employee has an association from employee and has an association to employee. Let's look at the next one, which is the one we're most familiar with. We have two boxes and one line. Known as association, there's no arrows, so it's unspecified. So when we're looking at traceability, we see that customer is associated to product. And when we go to product, we can see that product is associated from customer, all right? And then there's something called composition in associations. And that's when we put a directional arrow on either side with source or direction. So this is the source and this is the target, right? So here you see an association that a car has a form of composition, one motor, known as multiplicity. We'll get into multiplicity in other later sessions. And a motor has one car, has a car. Now down here, we see that a car has a wheel. And in this case, multiplicity, one to many wheels. Most of us know that a car has 4 wheels, but it's variable. Right? So these are forms of association when you're telling your story and the notion of traceability in that story that you're telling. Now, since I used the T word for traceability, let's show you how to get to the traceability tooling. Now, for me, you can see it's over on the right side, lower right side. For you, depending on your workspace layout, it could be in various places. But let's go ahead and cancel this for a second. And let's move traceability just up here, anywhere in the screen, and let's delete it. Let's remove it from our workspace. So now we don't have traceability, right? So the first way to get to it, probably the easiest, is from the Start tab. Go to Design under All Windows, Design, and simply click on Trace. And there it is. Let's close it and show you the next way. The next way is go to the Design tab. And in the Design tab, if you go over to the Element Group or panel, you'll see Trace. We'll turn it on and you can get it to it that way. And you'll notice when you mouse over Trace, it gives you the shortcut, Control+7, in order to launch that. Let's go ahead and do that. So right now, we're going to go ahead and hit Control and 7, and we're going to pop it up. Now, some who like shortcuts, that may be the easiest way to bring this up. However, I normally have this in a particular place within my model, and that's in the lower right-hand side. And I'm going to drag and drop it. I like to have it just to the right of properties. So that's how you get to the traceability tooling that we're going to be talking about in this session. All right, since we talked about traceability, the next thing I want to talk about before we get into the next chapter or subject is roles. And so I'm going to go ahead and select association right here between these two elements. I'm going to go ahead and double click on it. And within the dialog here, you have a selection called role or roles. And you can see that in this case, you have class 1 or object 1, and that's the source. And you have the target, class 2 or object 2. That's your target. And we're going to get into roles in more advanced session, but you're able to come up here, make selections if you have them, or free-form type your own selection for the role of source and the role of target. And you can put in a brief description here. This will become very important later on when you're telling your story. Then we get into multiplicity. you can come in here and select multiplicity for source and multiplicity for target. But as we get into aggregation and composition, I want to be talking about aggregation. And right now, because this is an association, there is no form of aggregation. And you have two, you've got shared and you have composite. And you'll see that when we get into that subject. But I wanted to touch on roles, which is a more advanced area. And I also wanted to warn you that if you don't understand how roles work in UML or in Sparks, this can be a dangerous area. You may mess things up if you don't know what you're doing. So play around with this over in your training environment, set some various roles between source and target, and you can see what happens. We're going to see a little bit about that in the next subject. All right, next we're going to get into composition and aggregation as a connector type and telling your story. And so you can see here in this first example that the source in this case is class 2, where the target is class 1. How do I know that? I don't need this arrow here to tell me that. In fact, the arrow is not necessary, and it won't show in modeling tools if you're using composition or aggregation. And I'll show you that in just a moment. But the closed diamond for composition and the open diamond for aggregation will be on the target side of your connector or your relationship. All right, so let's go ahead and open the first model. So the first model here shows a combination of composition and aggregation. So a power source has a smartphone, right? And it's using aggregation, an open diamond. A camera within the smartphone, camera owns a smartphone. That's what composition means with a closed diamond on the target, right? And then web browser owns a smartphone, and then the music player contained within the smartphone owns that smartphone, right? And the difference between aggregation and composition is kind of hard set. And again, I want to make sure I'm clear. You don't need these arrows. I drew these in here years ago when I created this model for teaching purposes, right? But if the smartphone goes away, and let's just remove it from the diagram, then the camera, the browser, and the music player in this case, they go away. And the IMEI, and I'm not going to get into what that means, you can look that up yourself, that goes away. So this type of composition means that if the target goes away, so does everything connected to it. All right, so let's go ahead and Control Z and bring these things back in. On the other side of the fence, if the smartphone goes away using aggregation, the power source doesn't go away. You can take a power source out of a camera. Most devices in this case were stating that the power source is not a composite or owned by that particular device. That power supply can be pulled out, can be put in another device that's compatible with it. So this is the story that you're telling in this particular model. Let's go to another example. In this case, we also are using a blend of connector types. We're using composition or composite connector type. We're using aggregation. And in this case, we're using generalization, right? Sorry, I didn't mean to click on that. And we're using generalization. And we're going to talk about generalization in just a moment, right? So in this case, we're stating that a department owns a university. And if the university goes away, so does the department. But we're also stating that a professor has a department within the university. And if the university and or the department go away, professor doesn't go away. And that's the story that we're telling using aggregation in this case. And again, I'm not going to get into multiplicity, but that's what that means, right? So a person, and we're going to talk about generalization here shortly, and that's just basically mean that a person can be a professor or it can be a parent within a student of that university, all right? So we'll get more into that, But that is what composition and aggregation is about. Before we get into the next subject, I did want to come back to what I told you I was going to talk about as far as roles. So in this particular case, we're using composition, and in this case, we're using aggregation. So let's go ahead and double click on the first one, which is composition, and its form of aggregation. You can see in the property windows that it says aggregation here. We're going to go into roles. So in roles, the source is the department, and the target is university. Let me drag this down a little bit. The source is department, and the target is university. So if you come down here in roles and you're looking at aggregation, you'll notice over on the target where the closed diamond is that the aggregation is composite, all right? So very important to understand if and when we get into roles, you get into roles, what that means. Let's open up a composition. So in composition, again, it's a form of aggregation. Let's go to roles. In this particular case, you can see the target, which is department. The target is department, that the form of aggregation is shared, right? So it means that it's sharing with the professor the use of department within the university, right? And again, when I told you the university goes away, the department goes away. So therefore that shared resource goes away. But in the case of the department, if the department is there and the professor is the source using that department, it is shared. So that's the difference between composition and aggregation as far as connector types in telling your story. All right, next we get into one of the most important ones in modeling connectors, and that's generalization. Generalization is very important in object-oriented architecture, design, and development. And so when we're talking about generalization, it represents the fundamental association in OOA, object-oriented architecture, development, and design. And using generalization in order to tell your story provides a means of extracting shared characteristics from two or more elements, if you will, and combining them to generalize a superclass, right? And from that, or those shared abilities, you share characteristics that can be attributes, operations, and other things that you're going to see in a moment. So let's go ahead and jump right into it. So when we're talking about generalization, we're referring to inheritance, and we'll get into inheritance, polymorphism, and so on in later subjects, later sessions. But in this case, we have a superclass, which is a fruit. And that fruit has an apple, an orange, and a mango. So you can see that an apple is a form of fruit, is a kind of fruit. An orange is a kind of fruit, is a fruit. And a mango is a fruit, right? So this is your superclass, and here are your subclasses that are here. So when we're talking about inheritance, you can see that we have an animal as a superclass, and then we have two subclasses in this case. We have a cat and we have a dog. And so an animal has a name and an age. These are attributes, and has various methods. We just listed two here. They eat and they sleep, all right? And then I'm not going to get into tags, tag values in a later session. But a cat has a name and an age that's inherited, and it eats and it sleeps. So does a dog. But what are the differences between these subtypes or these subclasses and the superclass? Well, a cat meows, a dog barks, right? And then there's, when you're getting in the tags, and again, cover this in deeper sessions, you can see that you can do custom forms within your elements and your objects to help tell your story that further define that element or their object. And in this case, we're talking about breeding cycles, and we're talking about version of cat. Breeding cycles different between a dog and a cat, and those kind of things when you're telling your story. But this is generalization right here. And so when you're looking at generalization, there are no roles in here. And we'll talk about that more in later sessions when we get into generalization. But if we go to Go back to composition, which we're going to do here when we're wrapping up. You're going to look at the roles that we talked about earlier in the session that in telling your story. All right. So the next one we're going to get into from generalization is realization. All right. Next is realization. And realization is one of my favorites. It's just as important as generalization. So let's jump into realization. So in this particular case, we have an interface called steerable, steerable. And we have a boat and we have a truck, right? So we look at traceability in this case, we see that a boat implements this interface and a truck implements this interface. So realization is the same thing as saying implementation or implements when you're telling your story. So when we're looking at these objects here, you can see that realization, the terms that words I use are acts like a. So if we go here, a boat acts like a steerable something, right? A truck acts like a steerable something. So very important to understand when you're telling your story and you're using realization, because when you get into requirements engineering and you have your scope or requirements, you're going to realize those requirements. So the source is going to be the requirement. The target is what it's realizing. So in that particular case, when you have a requirement, your requirement is implementing whatever the elements you're pointing to. It could be a function, could be a system, could be anything that you're modeling when you're telling your story. So as we're moving between realization and generalization, and we're looking at traceability, you can see that in traceability that the boat implements steerability. And in generalization, it's just telling you or telling the story that an apple is a subtype of fruit. All right, so very important to understand these very important types of connectors, types of associations as you're going into it. All right. So the next one is dependency. And this one we could talk a whole hour on. So I'm just going to touch on dependencies. All right. All right. Last but not least is dependencies. So when we go over to a sample model that I have here, I have several elements in here that are dependent on other elements. So the first one is component A, where is the source, and component B is the target. All right. So in this case, if we go to traceability, component A depends on the interface for component B. All right. And down here, we have a source and we have a target. And in this case, we're looking at traceability. Source depends on the target. Now we see a stereotype here. And again, we'll cover this in another session. You can use literally dozens, if not hundreds of different types of stereotypes. We can see that a source instantiates the target, right? So it's needed by the target in order to do that, all right? In this case, client package and supply package, right? So we look at the client, we can see that the client's needed by the supplier and depends on the supplier. So what I want to do is I want to remove this and do these one at a time. All right. So here's your source. How do I know that? The arrow's over on the target. All right. And here's your target. So when you're looking at this, client depends on supplier. All right. So if I bring those associations back and let's remove this one and we click on client, we can see client is needed by the supplier. So here's the source side and here's the target side. Now down here is interesting. Let me remove this, all right? Now click on it again. The client is needed by the supplier. The supplier depends on the client. This is the story you're telling using dependencies. And again, a stereotype supply. So the supplier is supplying the client and the client needs the supplier for that stereotype supply, all right? So let's bring back this one right here, and I'm going to remove this one, and let's talk about this form of drawing the connection, right? So the client depends on the supplier, and the supplier is needed by the client. Well, what's the difference between the other two that are there? Let's go ahead and double click this and open it. All right. So the term that we put here, and not stereotype, is import. All right. And I'll talk about how to draw this form, draw this line. And I talk about it in a later session, but we'll talk about it a lot more as we're going forward. It says what that dependency is within the notes that are here. But if we go to roles, we can see the source is the client and the supplier is the target. So the line is going this way. So if we were to draw an arrow in here, the arrow would be over on the target. Right? So it gets a little confusing when you're doing it this way, because you have this arrow that's going this direction. I'm going to go ahead and cancel this. We're going to go back to traceability. The client depends on the supplier to import goods this direction. So the dependency arrow would be over on this side. So let's open this up again, and then let's go over here to direction. It's unspecified. So if we were to do source to destination and hit OK, now you would see the dependency arrow that's in here. But this is another form of showing dependency between two elements. In this case, these are packages, right? So here is telling a story. And if you're looking at the elements that are here and the different connector types that we have here, what kind of story do you think we're telling here? Right? If a picture speaks 1,000 words, well, what are the 1,000 words that you're reading from this picture? So we have a customer who is a user. We're using generalization. An agent is a user. The customer depends on the agent. The user is part of the target, which is our co is a fictitious company online, an e-commerce site. And the user has a dependency with a stereotype, uses the OurCo online. I'm just going to refer to it as e-commerce at the site at this particular point. And you can see here composition of access management. So the source is access management, e-commerce is the target. So in this case, if access management or online goes away, access management goes away, all right? So there's different ways you could draw this. Like for instance, hey, we don't have access management, therefore we don't have an e-commerce site. Well, that's not true. It's just users are not going to be able to log in on the story that you're telling or within the scope, right? So the e-commerce site has a shop, has track orders, payment, and a help center, right? So these are sources. Here's your target for shopping. So if the e-commerce site goes away, can we still shop? The answer in this case, the story we're telling, is yes. Do users go away? Well, the story we're telling is no if the e-commerce site goes away. Might be hard to do business, but that's the story we're telling. Track orders, payment, and help center. So if we go to diagram and we select each one of these elements, we're in the browser, we're going to go to diagram, probably could do the same thing from target. With traceability, the story we're telling as we're going through this in alphabetical order is access management is part of online, right? The agent is a subtype of user, right? Needed by the customer. That's the dependency that you see here. And depends on help center. The agent depends on the help center for knowledge management, methods and procedures, training guides, support guides, all those kind of things, right? And if we go to the next one, which is customer, again, subtype of user using generalization, and it depends on the agent for help and other things. You would tell that story within the notes underneath that connector, right? And we go to help center. Help center is part of e-commerce site, right? And it's needed by the agent to conduct business. OurCo online is composed of the things that we already talked about, and it's needed by the user. And the user could be a customer, it could be an agent, could be many other types of users that's there. And so we're telling a story in each one of these scenarios, these areas of scope, these systems, software. We can go on and on. but we're telling a very valuable story using the various types of connections in UML to tell that story. All right, and we're going to touch on this quite a bit more as we get into our architect series, what a software architect is, system architect, enterprise architect, business architect. We're going to jump into pretty broad series of videos, and we want to be able to reflect back on connectivity between the elements in which we're modeling. All right, we're going to wrap up now. I hope this session helped you. Get a lot of questions about connection types, what they mean, and more importantly, when I'm working with modelers, they're having trouble telling their story. Whether they're non-technical or technical, understand UML or not, they're having trouble telling their stories. Very easy to do in Spark's Enterprise Architect. A little harder to do in typical drawing tools that are out there in the industry because they don't have enough intelligence underneath the connection types or the elements to help tell your story. So you have to tell your story off on the side, or you have to count on people understanding what the connection types are, whether you're talking about associations, composition, aggregation, generalization, and so on. So we're going to be talking about this a lot, and I'm not going to spend as much time getting into the connector types that I'm using. So hope I'll try to draw reflection back to this. Thanks very much for watching. And please leave comments down below, good or bad. Let me know what you think, what you don't think, what you know, what you don't know, and we'll try to support you the best we can. Until then, happy modeling.